Okay, so today is 1.4, and we are going to be solving absolute value equations. Solving absolute value equations. So we're very familiar with absolute value. I'm just going to write some notes here up at the top, just a little review. But by definition, the definition of an absolute value is the distance away from zero on a number line. So let's say, for example, I have this number line. Here's 0. Let's say I have -4 and +4. The distance away from 0 on a number line between 0 and 4, this distance is 4. The distance from -4 to 0, this distance is 4. Distance or the absolute values are always positive. And I always thought of it this way, like if I drive my car from here to Kalamazoo, and let's say it's 20 miles, and I drive 20 miles to Kalamazoo, and then 20 miles back, my odometer on the car is gonna tell me that I drove a total of 40 miles, 20 there and 20 back. Those distances are positive. It doesn't say that I went 0 miles because I drove 20 this way and 20 back in the same direction. It doesn't tell me it's 0. It's going to tell me it's 40. That's the way I think about it. So if I have the absolute value of -2, the absolute value of -2 is +2. So we're talking about that distance away from 0. -2 would be right here. The distance from 0 is going to be positive. It's going to be 2. We keep that distance positive. There's some properties we're going to look at. Properties of absolute value. And we're going to use some letters, just like I always do with our notes. I'm going to say let A and B be real numbers. In Algebra 1, with the exception of one little section, we are going to be dealing primarily with real numbers. The opposite of real numbers is an imaginary number. If I put in second the square root of 4, square root of 4 means what number times itself gives me 4. And I hope that you could tell me that the square root of 4 is 2. Square root of 9 is 3. Square root of 64. Hopefully you can tell me that's 8. Why is it 8? Because 8 times 8 gives me 64. Why is the square root of 9 3? Because 3 times 3 gives me 9. What if I put in, though, the square root of a negative number? It tells me an error. Why would it tell me an error? Well, think about the definition of that square root, or any even root for that matter. I have to take the same number times itself to give me a -4. If I'm using the same number, those values would have to be 2 and 2. But in order to get a negative product, one needs to be negative, one needs to be positive. Are -2 and +2 the same? They are not. That's why we cannot take square roots or even roots of negative numbers, because I have to have something times itself. We're going to get into that more. We certainly can take the square root of this -4, but we'll be doing that in a future chapter. Back to it. A and B are real numbers. First thing, the absolute value of A is always going to be greater than or equal to 0. What sort of numbers are greater than or equal to 0? Well, those would be positive numbers, meaning the absolute value, if I take the absolute value of any number, it cannot be less than 0. It cannot be negative. It has to be positive. They are all going to be greater than or equal to 0 because they are positive. If I take the absolute value of something negative, that is going to be the same as taking the absolute value of something positive. If I plug in -6 for A, or I'm sorry, 6 for A in both of these, this would be the absolute value of -6, which would be +6. This would just be the absolute value of +6, which is 6. 6 equals 6. That makes a true statement. I can also take A times B, the absolute value, and that just splits up into the absolute value of A times the absolute value of B. And you can certainly plug in numbers in here. Let's say I use 2 and 3. 2 for A, 3 for B. 2 times 3 would be 6. The absolute value of 6 would be 6. If I plug in 2 for A and 3 for B here, the absolute value of 2 is 2, times the absolute value of 3, which is 3. 2 times 3, it would give me the same thing. It would give me a +6. We can split that up. On the flip side of that multiplication, I can also do the absolute value of A divided by B with division, which is going to simply be the absolute value of A divided by the absolute value of B. And again, if I put in, let's say I put in a 6 and a 3, 6 and 3. 6 divided by 3 is 2. The absolute value of 2 is 2. If I use A is 6, B is 3, absolute value of 6 is 6, absolute value of 3 is 3, 6 divided by 3 is 2, 2 would equal 2. It's going to work. We do have to put a limitation on this one. We will say B cannot equal 0. Back to our first lectures in there, if I take any number and I divide it by 0, it tells me divide by 0, error. And if you remember what we called this, I'm just going to make a note. 0 in denominator, we call that undefined. And we mentioned this earlier, and we will continue to mention it as we go on. It's undefined. Now into the nuts and bolts and the examples. And we got a lot of examples and a lot of stuff to cover. There's going to be a lot of concepts, each of which are brand new to you guys. So you may have to go back and watch this video once or twice for sure. If you don't, you're going to struggle. We're going to solve and graph if possible. The absolute value of x subtract 4 is equal to 6. Again, what this is saying is whatever this is inside of here, I don't know what it is yet because I haven't solved it, but what it's saying is if I take the absolute value of whatever x minus 4 equals, it should be a +6. Well, what does this have to be in order for it to equal a +6? What's inside here would have to equal a 6. Or it could potentially be a -6. Because if I take the absolute value of a -6, it's going to give me a +6. The key takeaway, and I don't care how you star it, highlight it, for every absolute value equation we solve, we are going to need to set up 2 equations. Why? Because I have 2 potential answers. The absolute value of 6 would equal 6, but the absolute value of -6 would also equal 6. And I have to find out what would make this inside 6 or -6. Here's how we set up our 2 equations. The first one I set up, I just dropped my absolute value symbols. X minus 4 is equal to 6. Or that x minus 4, we said, could also equal a -6. Drop the absolute value on both of them. One of them it's going to equal the positive, one of them is going to equal the negative. And again, back to it. Because if I take the absolute value of -6, it's +6. These are what I need to solve. This one I would add 4 to start. X then, that would equal 10. Big mistake people make is from this step right here, they're saying, well, if this is 10, then this one's got to be -10. But does it work? Plug in 10. 10 minus 4 is 6. The absolute value of 6 is 6. That works. But if I make that a -10, -10 subtract 4, that's a -14. Even if I take the absolute value of a -14, which is +14, that doesn't equal 6. I can't just take the opposite of what I get for one of them. I have to set up two equations and solve both. And I will see when I solve this, it ain't close to 14. -14. Or I'm sorry, -10. It's 14 if I plug it in. It's not going to be -10. This x stays. -6 plus 4, that's a -2. Now if I plug this in, -2 minus 4 is -6. Absolute value of -6 is +6. That checks, that checks. You have two potential solutions. Both of those work. Both of those satisfy the equation. We're going to put this on a number line. Because a number line, if you understand the number line and you understand how absolute value relates to 0 and that distance from it, it will help you write equations as you go. I'm just going to make a simple number line. I will go by 2's, and I'm going to graph my solutions on it. I have one of my solutions which is at 10. I have one of my solutions which is at -2. And again, I'm going to go back to my definition of absolute value. I'm just going to lightly circle this number 4 right here. What's special about that number 4? Well, I will let you know that the number 4 is exactly 6 away from 10 and exactly 6 away from -2. So how this relates to this is what would make this 0 in here. Because the absolute value by definition is the distance away from 0. Well, if it was a +4, it would be 0, and the distance away from that 0 would be 6. This distance right here is 6. This distance right here is 6. It is the distance away from 0 on a number line. Well, I know this isn't 0, but if I plug a 4 in here, it makes it 0, and that's the difference. Number lines will help you see it. It is the distance away from what makes that equation 0. I need to flip my paper over. Next example. I have the example, the absolute value of 3x plus 9, subtract 10 is equal to -4. I'm going to make a key note over here. Whenever you are doing absolute value equations, the first thing you want to look at, the first thing you want to do is isolate the absolute value. We need to isolate it. We need to get it by itself. We need to get this alone. Just like if this whole thing, I could think of this is what we're solving for. This would just be like x minus 10 is equal to -4. Well, you would tell me I would add 10. X would equal 6. I need to take that same logic and get this absolute value by itself. Which means my first step is going to be to add 10, which I will do. I'm left with the absolute value of 3x plus 9, that goes away. That's what I want. Negative 4 plus 10 is equal to 6. Once I'm at this step right here, my absolute value is isolated. I am ready to set up two equations. One of them will be 3x plus 9 is equal to 6. I just drop my absolute values. Or remember, what's inside of here could be negative 6 because the absolute value of negative 6 is positive 6. So I also have the equation 3x plus 9 is equal to negative 6. Those are the two equations I need to solve. I will solve those. I can see my steps here are going to be exactly the same. I'm going to do these out kind of like this. I'm going to do them, so I'm going to be doing the same thing. 3x, that goes away. 6 minus 9, negative 3. Do the same thing over here. 3x would come down, that would go away. But now my sum is a little bit different here. Negative 6, subtract 9, negative 15. Divide all sides by 3. X then would equal negative 3 divided by positive 3 would be a negative 1, or x would equal negative 15 divided by 3, which is a negative 5. I can check these. Plug them back into your original equation right here. Negative 1 times 3, negative 3. Negative 3 plus 9, 6. Absolute value of 6 is positive 6. 6 subtract 10 would indeed give me negative 4. That one checks. Let's check negative 5. 3 times negative 5, negative 15. Negative 15 plus 9, negative 6. Absolute value of negative 6, positive 6. 6 minus 10 is indeed negative 4. Those both check, and I will box those in. Those are my two solutions. We'll amp it up a little more. 4 times absolute value of 2x plus 7 is equal to 16. Lots of mistakes happen here. I see a lot of students that tried to distribute this in there. We do not distribute inside those absolute values. We need to isolate this absolute value. We need to get this by itself. This absolute value you can think of as a variable. If I gave you the equation 4x is equal to 16, meaning I just took this whole thing, this unknown, and I just made it the variable x, you would say, oh geez, if x is being multiplied by 4, Mr. DeLong, all I do is divide by 4, x would then equal 4. Same thing happens here. I need to get this absolute value by itself. I do not distribute. What I need to do is divide both sides by 4. So these 4's divide into each other. So I can be left with the absolute value of 2x plus 7 is then equal to 16 divided by 4, which is 4. Now I have that absolute value isolated. So I can set up how many equations? Two equations. One of them will be 2x plus 7 is equal to 4. But also what's inside of here, this 2x plus 7, could also equal negative 4. There's the two equations that I solve. I would subtract 7, which means my 2x stays, that goes, is equal to 4 minus 7, which is negative 3. 2x would stay, that goes away. Negative 4 minus 7, negative 11. Divide everything by 2, because x is being multiplied by 2. X then would equal negative 3 halves, or negative 11 halves. And you could certainly have negative 1.5 or negative, whoops, not negative 6.5, be negative 5.5 as your solutions. And feel free to plug those back in using decimals to check it out. I'll do the 1.5 right now. If I double 1.5, that would be 3. It'd be a negative 3. Negative 3 plus 7, 4. 4 times, well, the absolute value of 4 is 4, and 4 times 4 is 16. If I double negative 5.5, well, that's 11. Negative 11 plus 7 would be a negative 4. The absolute value of negative 4 is positive 4. 4 times 4 is 16, and I've got it. I need another sheet of paper. This is 1.4 continued, but now this is solving equations with 2 absolute values. So the only thing that's going to be different on this is now I'm going to have an absolute value on both sides of the equation. Here's my example to start. I have the absolute value of 3x subtract 4. That's going to equal the absolute value of x. How is this different than what we just did? I now have absolute value symbols on both sides of the equation. I still need to set up 2 equations and I still need to solve. First equation, 3x minus 4 is equal to x. I just drop both absolute values on both sides of the equation. For my second one, and I hope your intuition is kicking in, 3x minus 4 then would equal negative x. Be the opposite of it. Because if x was negative, and I take the absolute value, it's going to make it positive. These are the 2 equations I need to solve. I will subtract 3x. I'll do these one by one, no reason why. Negative 4 is equal to x minus 3x is a negative 2x. X is being multiplied by negative 2. I would divide both sides by negative 2. Negative 4 divided by negative 2 would give me a 2 is equal to a positive x. Or you could say x equals 2 if your heart desires. Do the same thing over here. I'm still going to have to subtract 3x. Negative 4 then would equal negative x minus 3x is a negative 4x. I would divide by negative 4. Whoops, I don't need that line there. 1 is equal to x. Or you could have x is equal to 1. And I can certainly check these. If I plug in 2 right up here, 3 times 2 is 6. 6 minus 4 is 2. The absolute value of 2 is 2, and that indeed equals 2. The absolute value of 2. If I plug in 1, 3 times 1 is 3. Minus 4 is negative 1. The absolute value of negative 1 is positive 1, and that indeed would equal the absolute value of 1, which is positive 1. I am certain those are correct. They satisfy the absolute value equation, and I will box those in. Absolute value on both sides. We'll amp it up a little more. Here I have the absolute value of 4x. Subtract 10 is equal to 2 times 3x plus 1 absolute value. And again, I see this 2 out here. Do not distribute. We don't want to distribute there. I still need to set up 2 equations. I have absolute values on both sides. Sets up just like this. I drop my absolute value. On this second side, yes, this is 2 times it. So I take 2 and I am going to switch those absolute values to parentheses. That is what I need to solve. Or I would have 4x minus 10 is equal to the opposite of that, or a negative 2 times 3x plus 1. So the steps, as you can see, are kind of the same. The amount of work and the amount of error that can happen is going to increase as we go, because now I've got some distribution. I'm going to have variables on both sides, and I need to take special care in solving these. 4x minus 10 will stay. I will definitely do these one by one. 2 times 3x is equal to 6x. 2 times 1 plus 2. I've got some like terms to combine on both sides. To me, it makes a little more sense if I subtract 4x, I'm going to have a positive variable. So that's what I'm going to do first. And I always like to work with my variables first. That goes away. Negative 10 then is equal to 6x minus 4x is 2x. And I'm left with my plus 2. X is being multiplied by 2, added by 2. My steps then would be to subtract 2 from both sides. Negative 12 is equal to 2x. I would divide both sides by 2. Negative 6 is equal to x. Here I have 4x minus 10 is equal to, I've got to distribute. Negative 6x, negative 2 times 3x is negative 6x. Negative 2 times a positive 1 is negative 2. Now here, I'm definitely going to add my 6x first because that's going to make my variable positive. So I'm going to add 6x. 10x, subtract 10, that goes away, is equal to negative 2. X is being multiplied by 10, subtracted by 10. I need to undo that by adding 10. 10x stays. That's 0. That's what I want. Negative 2 plus 10 gives me an 8. I would divide both sides by 10. X then would equal 8/10, which needs to be reduced to 4/5, or you could even have 0.8. And if you plug those back in to those original absolute values, you will indeed see that they check out. Absolute values on both sides. Something special can happen though, and I need to flip my paper. When dealing with these, and actually dealing with in math, in science, physics, biology, chemistry, you can come up with what's called extraneous solutions. And there's a special case and something you got to look out for with absolute values when this happens. If I look at the word extraneous and I just look at the first part of that word, it says extra. It's an extra solution is what it is. Extraneous solution is going to be an extra solution. It's not necessarily going to solve it. The definition is an apparent solution that must be rejected because, and there's a reason we're going to reject it, it does not satisfy the original equation. What's that mean? It means that you are going to get an answer that when you plug that back in to the original absolute value equation, you are not going to get a true statement. You're going to get a solution for it, but when you check it, it ain't gonna jive, man. It ain't gonna jive. Here's what it looks like. Absolute value of 2x plus 12 is equal to 4x. Now I want you to think a minute. How does this look different from what we just did? Maybe this one right here. How is it different? There's definitely an absolute value, which we have here, but now I have a variable on this side, and notice what it's missing. It does not have an absolute value on both sides. It definitely has something on the right here, and that something that I'm referring to is that variable. When you have a variable on either side of the equation, and there's no absolute value around it, and you have an absolute value that's equaling that, you have the potential for an extraneous solution. And here's why. If I took like a value, let's say x came out to a -1. If I substitute -1 back in, I don't even care what this is over here. What I care about is over here. If I take 4 times -1, my product is -4. And my question to you is, if I take the absolute value of any number, it's always going to be what? It's going to be positive. So if I took the absolute value of anything, it's going to be positive. That cannot equal something that's negative. And if my x happens to be negative when I solve, that could potentially give me an extraneous solution, because what's inside the absolute value, the last step I do is take the absolute value, it makes it positive. It's impossible for it to equal something negative. That's where the extraneous solution comes in. I'm still going to set up 2 equations. One that looks exactly the same with dropping my absolute values, or 2x plus 12 could equal a -4x. These are the 2 that I need to solve. I am going to subtract 2x. That leaves me with 12 is equal to 4x minus 2x, which is 2x. I would divide by 2. 6 is equal to x. I can check that. I'll plug it right in. 6 times 2 is 12. 12 plus 12 is 24. The absolute value of 24 is 24. 4 times 6 is 24. That absolutely checks. Let's look at this one. I can see right now this is a potential issue. This is going to go away. 12 is equal to a -6x. And I can see right now, if I have a positive and I divide it by a negative, -2 is equal to x. This is an extraneous solution because my x is negative. Now, if I went through all these steps and it came out my x is positive, that's not an extraneous solution. So I have to take it all the way out to see, is my answer positive or negative? This happens to come out negative, which means if I plug it in, I don't even care what it is over here. But I can do it. 2 times -2 is -4, plus 12 would be 8. Positive 8, absolute value positive 8 is 8. When I plug that -2 in right here, it equals a -8. 8 does not equal -8. This answer is extraneous. It's an extra answer. It's an apparent solution, but I need to reject it because when I plug it back in, it doesn't satisfy the original equation. That's why we check it. Last thing we got to look at is absolute deviation. And you will use absolute deviation a ton if you are going into engineering or the real world, and we will definitely get into story problems dealing with absolute deviation. We'll give you a definition, and then we're just going to have to work with it. Absolute deviation of a number, and we'll call that number x, some variable, from a given value is the absolute value of the difference of x and the given value itself. So there's some key words in there that are going to help set this up. If I just take this and take it apart and write it, it's going to look like this. Absolute deviation would equal the absolute value of x minus a given value. Whatever that given value is in the problem. That's what it equals. I'm going to switch this around because this is how we're mainly going to write it. It's the absolute value of x minus the given value. That equals your absolute deviation. I didn't do anything special here. All I did was just switch it around because this is the way that you're going to set it up. And notice, it is going to be a difference. It's always going to be subtraction in there. There are many story problems that we are going to do dealing with absolute deviation and that concept. So I just wanted to introduce it and get it to you. What we are going to do is work through this problem set over the next 2 to 3 days and kind of breaking these down step by step. These are the notes for the entire section. The problems that are assigned, the 1.4 A and B, they are labor intensive. There's a lot of work with them, and we're going to take it slowly but surely and grind them out.